Hi, welcome to Market Board Videos. Today's video is about mechanical energy, and we're going to talk about the different kinds of mechanical energy and spend a few minutes talking about potential energy. So let's talk a little bit about mechanical energy. An archer. We've used this example before, the movie Brave, where she uses her bow and arrow all the time, or the movie Hunger Games, where she uses a bow and arrow. If the archer draws the bow back, the bent bow acquires the ability to do work. Okay? Rubber bands. We're all really fond of rubber bands, aren't we? If a rubber band is stretched, the rubber band acquires the ability to do work when released. Are we seeing a pattern here? Acquires the ability to do work, acquires the ability to do work. I know most of us don't wind our watches anymore, but you wind other things. You wind toys and that kind of thing. When you wind something, what you're actually winding is a spring inside, and that spring acquires the ability to do work. And those are all forms of mechanical energy. So what's happening, how do you get mechanical energy, is a couple of different ways. You may be compressing atoms. So you may be squishing atoms together. You may physically separate two things that attract. If you've ever done the magnet thing with paper clips or anything like that, you know that when you pull them apart, that paper clip wants to go to the magnet. It's attracting. Or you might be rearranging electrical charges in atoms. Now that's something that you can't see, but you can see the result of it. The property of an object to do work is energy. So remember I said that energy and work were hand in hand. Energy is actually defined as the property of an object to do work. So if an object can do work, it has energy. But energy takes many different forms. Mechanical energy, the kind that we're going to focus on, is due to two things. It's due to motion or it's due to storage. It's due to things being in motion, or it's due to things having the ability, the potential to do work, if you will. Kinetic energy is energy of motion. We're going to talk a lot about that in the next video. So if something is in motion, it has kinetic energy. No motion, no kinetic energy. But potential energy, this is the one I find really intriguing. It's stored energy. It's energy that's stored. So what do I mean by stored? Well, if it's stored and in readiness, here's what I'm talking about. That elastic rubber band or that bow that's just ready to let go. If you take a rubber band and pull it, you know when you let go, it's going to go flying. It's going to go a distance. So work is going to be done. So there's going to be some energy there. Chemical potential energy is one of the most intriguing ones. If you've ever looked at the nutrition facts for food, you see that it talks about calories. And we're going to talk about calories way later. But how does your body convert that cheeseburger or that Oreo cookie into energy? How does it give you the ability to work? Well, inside that cookie is some stored energy. Chemical energy is stored in there, waiting to be released to give your body the energy to do what it needs to do. The one that we see most often in physics, and especially in conceptual physics, is called gravitational potential energy. So gravitational potential energy is energy of position. If I have a ball and I have it up here, and let it go, it's going to hit the ground differently than if I have a ball that I have way down here, right? So it's based on position, and it's based on the fact that gravity is acting on it. Gravitational potential energy is usually abbreviated GPE, all uppercase. Gravitational potential energy is the amount of work done against gravity in lifting it. So work is force times distance, and force is mass times acceleration due to gravity. And when we say d, we're going to call it the height. So gravitational potential energy, the formula for it is mgh. Mass times acceleration due to gravity, there's your F, and h is your distance. Now, what is h? Is it height above the center of the earth? Is it height above the ground? Is it height above the table? Well, it's an arbitrarily decided number. Point. So if I had an apple and there's a table underneath it, that height is going to be the distance from the table to the apple. But if I don't have a table underneath in the floor, that height is going to be the distance from the apple to the floor. And if I'm on the 10th story of a building and I'm holding it out the window, it's not going to be the floor, it's going to be from the apple to the ground. So height, you need to know where it's going to land pretty much. And the distance from where it is to where it lands, that's your h. So let me give you a couple of different examples. Here's 3 different examples This boulder, 200 joules of work was done to get the boulder up where it is. In all three cases, the boulder is at the top of a cliff. The cliff is 2 meters off the ground in every single case. In this case, we simply took the boulder and pushed it all the way up to the top. We got it all the way up to the top. We did 200 joules of work to do it. In the red sample, we took and we rolled it up a ramp. Now the ramp is 4 meters long, but it still only has 200 joules of energy or work in it because the distance is still 2 meters. And in our third case, what we did was we took a stair step and we went up one stair, up the next stair, up the next stair, up to the top. Distance was more, but its potential energy is still exactly the same, 200 joules, because the distance is still 2 meters. So the route that you take to get it there doesn't matter for how much gravitational potential energy it has. It just tells you how far it is off the ground. MGH, mass times acceleration due to gravity times height.